Hi, this is Dr. Stephen Jones, and this is the video for the example for Module 7 for the problem that you've been assigned. This is the problem itself that you've been assigned. I've blown it up to make it easier for you to see on your screen, but essentially what you have is a list of activities with precededs and followed bys, optimistic, most likely, and pessimistic times, and these are very much like what you see in the text and we went through in the PowerPoints. And some people have wondered if you need Excel QM to solve this, and you do not. Now, Excel QM will do that for you, but you don't need that at all. In fact, all you need is just an Excel spreadsheet. You don't need Solver or data analysis or anything. I'm going to show you how to do that in this video example. I'm not going to do it with this one, obviously. I have another one, the one that I posted up there, that we're actually going to solve. The areas that you need to work on for the actual assignment out there, you need to come up with the expected times and the variances on it. You need to move it down. You'll notice that was the graphic out there to make it easier for you to visualize how this went down. Give me the earliest start, earliest finish, latest start, latest finish, and what the slack times are for each of those activities. You're given the budgeted cost per week, and your budgeted total cost here would be how many ever weeks that you have on the expected side for each activity times those budgeted costs per week, and that'll come out with a budgeted total cost there. And then here you would actually put in the number of weeks for each of activity and when you expect that you would actually enter each activity, and you do it by earliest start. You could do it by earliest start, latest finished, earliest finish, whatever. And I've asked you to do it by earliest start. Okay, so that's really essentially what you're doing. You're coming up with when those are and putting in those costs, and then the total cost per week and the total to date. And this is very much like what you see in your textbook. So let's go back and pull this aside, because I'm not actually solving that one for this video. And this is the one that you have your video example. Now, I've outlined in purple the areas that we're going to take a look at just to make it easy for you to see. You can do that, or you can just put the information in yourself if you prefer. So I've also put in on these examples the formulas that are in the text. Now, I did not have that in the original spreadsheet that I posted up there for you, because those formulas are available to you in the textbook. Now, I want to show a few things here. We're going to start off with the expected times, and this is just a formula. So you do in an Excel formula just what it tells you to do right up here. So your optimistic is 1 time, most likely is 4 times, and pessimistic is 1 time. And you divide the sum of all those by 6, which is the number of variables that you're putting in there. So we'd start off with this equals, you're going to need 2 of these to start off with, because we're enclosing several multiplications here. So we're going to start off by multiplying that by 1. I know that's just as if you just put it in itself. You could do that if you want to. You could just leave the D2 in there. But I want to do it just for emphasis so you see exactly what I'm doing. Then we're going to have another set of parentheses where we put this variable in there, and we do it times 4 because that's the most likely. And then we put the last one in, the pessimistic one, in there, and again we multiply it by 1. And then you want to sum all of those together and then you divide it by 6. So you see what we have here. We've taken the optimistic and put it in once, the most likely put it in 4 times, and pessimistic and put it in once. But you need your parentheses in there, because otherwise Excel will take a look at it and calculate it up using order of mathematical terms, and that may or may not work out, depending upon what you put in there, may or may not work out appropriately. Now I'm going to go ahead and hit enter on there, and it gives me a 2, and that's what you should get. If you copy this down, you're going to notice that you get right here, you get 2 other terms that are not in even amounts. Okay, now you could leave it in those terms. You could leave it the 3.83333 or the 2.16667. You could do that, but we're not actually going to do that for a number of weeks. For one reason, when you go down here to the bottom, it's going to be hard to have 2.16667. Where does that fall within this? So we need to round these off. And so that's what we're going to do. We're going to go back here and we're going to round. So you'll notice what I put round and then a parenthesis before that whole set of calculations we did. Then a comma, and then I tell it how many digits I want this rounded to, and I want it rounded to 0. I want it rounded off, and then put an end parenthesis on it. Okay, so it gives me the same thing that I had before, but notice what happens when I copy down now. Now what this done is it has rounded this down a little bit from 2.1667 down to 2, and it rounded 3.83333 up to 4. For these kinds of examples, that's fine, because these are still probabilities. These are not exact. These are probabilities. We're doing a budgeting here, and so we have to do what we consider to be the most likely situations that are going to go on, and we have to try to determine what is a budgetable amount of money. We're not trying to go to the moon, so rounding off a little bit doesn't hurt us. So hear that again, rounding off a little bit doesn't hurt us in this situation. Now we don't have to round over here with variance. Reason we have to with expected is because we're going to be using that for the budgeting, and we're going to be using that over here as well for when we place things into our calendar. With variance, we would be using variance if I'm having you calculate it anyway. Variance would be used in there in another set of equations that we're not going to go through. You just need to know how to be able to come up with it. But another set of equations out there that would be part of the calculations that we'd be doing for another test. So if we were trying to look at it and come up with the tentativeness of these schedules, then we would need the variance in there. And if we were trying to prove that we were going to be able to make a 15-week schedule when we've got 16 weeks budgeted out there, then we would probably need to use the variance as well. We're not going to do that with this exercise here. We're just trying to set up a budget for everything going on. So this is what we have for the expected, and I had you round those off so they come up to the nearest digit. For variance, you'll notice that we use the pessimistic minus the optimistic, and then divide that by 6 and square it. Pardon me there for a second. Okay, so we square that amount. So we go back in here and we're going to create our equation again. So in this situation, we again need to do the double parenthesis to start so that we can do b minus a, and then divide that by 6, then close out that parenthesis, and then square, pardon me, caret up 2, so that squares it. If we just put 2 out there, it's just going to multiply it by 2. Now you could just rewrite that whole equation and multiply it by itself, but that's silly. You don't need to do that. So the caret up 2 gives you the squaring for that equation. And I don't need it out to that many decimal points, so setting this as a number with 2 decimal points is plenty. We don't need to go into any more detail. If you actually do have 0.1111, 6 decimals, I'm not going to count it against you. It's just that's unnecessary. You don't have to go there. So now we have our expected times and we have our variances out there. So we're going to use that same information. I'm going to open this up just a little bit more down here. And we're going to use earliest start, earliest finish, latest start, latest finish, and slack down there, and then come up with budgeted total cost as well. So we know that our earliest start for A is 0 because it's the very first thing. That's where that's going to be. That's 0. Now the earliest finish that we have, we're expecting out there to for this to take 2 weeks. So our earliest finish is going to be this expectation right here. And we can just do 0, pardon me, not 0, equals, and then our expected time. And that gives us the earliest finish out there. We can't do the latest just yet because we have to see where we're going to stop. And we don't have that point down here. We don't have these starts and finishes down here because we're going to work back to get the latest starts and latest finishes out there. So with that being the case, you'll notice that this right here is the earliest finish, and that's what we're going to use to be able to come up with our earliest starts for each of B and C. Notice that A is followed by B and C, or in your graphic, B and C follow out there. So B and C can't start until A is done anyway, so equals that. The reason I don't just put the number in there is if I determine that I did something wrong, with my formulas in here, it will help me to immediately be able to correct. And I need to do the same thing with C because it starts at the same point as well. Now, you probably see a pattern here because what you're going to see is that I'm using those expected start dates out there to help me understand the earliest starts out here plus the expected completion times out here to help me determine when each one of these things has to occur. So I need to do, for this one, for B, I have to base it on when my earliest start for the activity is, plus how long it's going to take for that activity to go on. So I use its earliest start plus its expected duration time, and that gives me the earliest finish for that activity. Same thing is going to happen here. I use the earliest start for C, add its expected time, and there you go. That's the earliest finish for this one. Now, D is based on B. Because D is based on B, it can't start before B finishes. So the earliest finish for D is going to be, the earliest start for D is going to be the earliest finish for B. And the earliest start for E is going to be the finish for C. Now we've calculated both those out. Well, this is going to be the same kind of concept. This can't start until after it starts. So to come up with its earliest finish, when is its start and how long is it planned to take? And that's a 2. True. And then F starts after D and E. Oh, now wait a minute. Because D and E don't end at the same time. Which one would F start after? Well, it's got to start after both of these have completed. So what you're looking for here is a maximum. What's the greatest? Now again, you could just put that number in there, but again, if we make an alteration to any of these numbers here or any of these earlier, that's going to affect these later numbers. So instead, I do max, and then I have it look at the max between those two, and it gives me the 8, which I knew it would do. So the earliest finish is this one right here, plus how long its duration is, and it goes to 10. So we know that 10 is the earliest that we're going to finish here, or is the maximum amount of time that's going to take. That means 10 weeks for the entire process. So we're going to start here with the latest finish being that earliest finish over here. We're going to look at going backwards through this entire process, okay? So your latest finish is going to be the same thing as your earliest finish over here, because that's how long, the longest amount that it takes for all of these. Now, with that being true, then how would you come up with the latest start? Well, how long does the F activity take? It takes this minus its actual length. Okay, its actual length is the 2 weeks. So you use that to calculate when the latest start is. It can't start any later than 8, or this 10 is going to be late, going to be delayed. If you start at 9 and it's 2 weeks long, then it's going to be 11 instead of 10. So we just work back just like we did before. Okay, so the latest finish here is going to depend upon what happens right after F. Well, if what happens right after E, and since D and E both lead into F, D and E are both going to have 8 as the latest finish. So this shouldn't make a difference, because we can already see, and we'll see it more so when we get to slack, but we can already see that 8 is the finish time for E, but it's after the other finish time, the earliest finish time for D. So there's going to be a latest start here. So D's not looking to be on the critical path. Looks like critical path goes this way here, not this way over here. So what do? We do the same thing that we did down here. We take this latest finish and subtract the amount of time that it actually takes us to do the project. And the same thing here, minus what it takes us to do that project. So we could actually wait a couple of weeks on D. Then we go up here. So C now, C comes before E. So we find the start here for E, and that's our latest finish time for it. and we do just like we've done prior to that. That minus how long it takes us to do, and 2 is our latest start to keep us on track. B comes before D, so the latest start for D is 6. And blunk. And it takes us 2 to do that. And now we know that A comes before B and C. So its latest finish has to be the smallest of B and C. Notice, if you remember right, when we got down here, our earliest start had to be after D and E. We had to max between these two right here because we had to wait until both of them were accomplished. Okay, so your latest finish here is going to have to be the least of these two starts right here. Why? Because it's got to get done in time for whichever one of these has to go first. So let's go back to this. In this case, you min between those two. And that means its latest finish is 2. And so, not surprisingly, 2 minus that expected is 2. Now, your slack time. To calculate up your slack time, you're going to be looking either at earliest start, latest start, or earliest finish, latest finish, etc. It doesn't matter. It's going to work out the same. We're going to do with the starts here. So in this case, what you're looking at is the difference between the two start dates. So latest start minus earliest start, and that's a 0. And I'm just going to pull that down all the way here. Whoa! Sorry. When I did my calculations here, I have obviously done this incorrect. Minus this, 2 this, minus, just one time minus. Somehow when I did this, and my copying down, I messed up, so I'm going to do it one by one. I know it takes a little longer, but that's just how it goes. There we go. What does this tell you? Well, you look at where it's a 0 means that it's on the critical path. Okay? So A, C, E, and F. And that's what we see right here, A, C, E, and F. That's the critical path. So the slack times of zeros tell you that those are the critical paths, and that B and D are not on the critical path because it's got some slack time in there. Now let's go over here, budgeted total cost. Well, your budgeted total cost is going to be the number of expected weeks times the budgeted cost for that week. So budgeted cost for the week times the expectation for that week to do 22,000. And you should be able to copy this down and have no problem. So there you go. Now here's an interesting check for you. I'm going to do this, although you're not required to. I'm going to sum these right here. And what you're going to see is that number should be the same number when we get down to the bottom here. Should be the same number that we get for the total that we've spent for the whole project. Okay. Now we get to the bottom of this activity. And A is $11,000 per week, and it takes 2 weeks. So we need to put that in here, 11,000, right there. Now B and C, we're using the earliest starts, okay? So B and C are going to start in week 2. If we did the latest, it'd be different. We'd have a different budget out there, but we're going to look at the earliest starts. So B is going to be 12,000 to start off, and C is going to be 13,000 to start off. Now, I haven't put the number of weeks in there because I'm just using this as placeholders here. B takes us 2 weeks, C takes us 4 weeks. So I'm going to copy that down 2, and I'm going to copy this down 4. Okay. Now be careful if your Excel is set up to where it would, instead of doing 12,000, 12,000, it'd go 12,000, 12,001. You want to be careful what numbers get pulled down here. And that is simply because sometimes Excel will one up instead of doing an exact copy out there. So kind of watch it. Now, D can start in week 4. Well, after week 4 there. So we're going to start D over here because, again, earliest start, and it's 14,000. Because we can work on D for a little bit if we want to. D is 14,000, and it takes us 2 weeks. So we'll do another 14,000 there. And E has to start after week 6. So E is going to be over here, and E takes us 15,000. And it takes 2 weeks as well. And then F is going to start here because it's got to wait for both D and E, so it starts after week 8, and it's 16,000. And it takes 2 weeks. Now, that's your layout. So I'll just put these numbers in here, 11, 12, 13, 14, 15. It doesn't matter what the numbers are. We're just putting those in there. These are our estimations. So now what I want you to do is total up for this week. So you will sum for that week all the way across. And you don't have anything going on in the rest of those weeks, that's fine. That's not a problem. So what you need to do now is just pull this down, and it's got the sums across for each week. And that's your total for each week out there. Then you have the total to date. And what that is whatever the first one is added with each week's totals after that. So we have nothing for the first one other than what's in that one. So I'm just going to put this number in here. Now this number should be our current week total plus what we had before. So those are the two numbers that we're going to add together. So this plus this, current week plus last week's, and add those together. Now I should be able to bring those down here and come up with my final total. And notice that equals that. And that's just the way it ought to be, folks. You don't have to put this number in there, but it's a good check for you to make sure that you've done everything correctly. That's how you solve this problem, folks. That's as easy as it is. No Excel QM, no calculus, no superpowers or anything like that. That's how you solve this. Y'all take care now. Bye-bye.